is Nick Pasetsky and
Madeline Messiah.
the U substitution video for calculus. So we're going to explain U substitution. And so first, we're going to talk about the chain rule, because this is almost like a reverse chain rule, but it's much more complicated than that. So you know that the derivative of f of g of x is equal to f prime g of x times g prime of x. And we also know that if we wrote it in antiderivative notation, that big F of g of x, the derivative of that would be equal to simply f g of x times g prime of x. And now we have the question of what do we do in a situation like this, where we have the integral of f of g of x, that's a g of x, times g prime of x dx. And we know that is equal, by the rule, to big F of g of x. But we can more simply write that as integral of f of u times u prime equal to f of u, big F of u, in the antiderivative. And so to explain the u substitution part, we'll use integral, what we had for f of g of x, times g prime of x dx. And this would be and we'll show the first step of u substitution, which is you're going to name u, which here is going to be g of x, and du, which is going to be g prime of x. And once you have that, integrate with respect to u, like this. So, and that's step 2, integrating with respect to u. And then once that's all said and done, for the next step, you simply take what you have, which will be big F of u, and put the u back in, and you know u is equal to g of x, so you will get, as the final antiderivative, f of g of x, like we showed earlier. But before we can go into all the rules of integration, like power rule and trig rules, we need to understand what u means. U is just a name. U and du are notation, and you need to understand the notation. U is equal to f of x, okay? And then u prime, or du over dx, the same concept of dy over dx, y prime, equal to f prime of x, that same fx that's up there. And so du is simply f prime of x times dx. Taking u and du are the most important parts of u substitution, and it really determines what your final what your final answer is going to be. Prime example, one of the best rules we have for integrals is the power rule. The power rule is the integral of u, or antiderivative of u to the n du is equal to u to the n plus 1 over that n plus 1. And don't forget plus c. We didn't talk about it earlier, but if you knew the integrals, plus c is very important. That is a constant that could have been lost. It's very important with indefinite intervals when you're trying to find those equations. Now we're going to do a straightforward power rule example. This is one you might see a lot, or it's the same type of idea. You might have something where they ask you to find the antiderivative of the square root of 4x, something like that. You know, what we have here is 4x minus 1, and of course dx. And so first, you need to recognize that the square root is really to the 1/2 power, so it would be 4x minus 1 to the 1/2 power. And so now you need to decide with what is going to be u and what is going to be d, and therefore du. So u here, where you're going to decide is 4x minus 1. And so du is very simple here. It'll just be 4 times dx. So now that you have u and du picked out, you can rewrite it with u substitution. But we need to remember something, which I almost forgot myself, is that du here is 4x. And so what you need to do is you need to make it so that you have that in here. And so the best way to do that is to throw in 4 on the right side of the integral. So you now have 4 over there. But then on the left of the integral, you need to counteract that with 1 over 4. Got to be aware of this. It's going to happen a lot. And this is where a lot of people struggle with doing u substitution. And in all honesty, u substitution is very important. So please listen. And so we know now we can put in the u and actually do the u substitution. So we got to rewrite this 1 over 4. Keep the 1 over 4 on the outside because it's not going anywhere. So 4 is du now. 4 dx is now du. And so you get 1 over 4 antiderivative of u to the 1 over 2 power. That's a 2 du. And that turns into, got to keep the 1 over 4 there, times 2 over 3 u to the 3 over 2 plus c. And so now at this point, you can put in u and do some simplifying. And so you do some simplifying, and you put in u, and you put in 4x minus 1 where u is, because that's what it is, and you will get 1 over 6 times the quantity 4x minus 1 to the 3 over 2 power, the 3 over 2, plus c. Do not forget the plus c. And that is how you would do that.
So this is an example of u substitution. Problem is the integral of the quantity tangent theta times the secant squared theta d of theta. And so for this problem, the tangent theta is replaced by u, and the secant squared of theta d of theta is replaced by du. We have the u equals times the theta, and the du equals secant squared of theta times d of theta. And then I wrote out the integral of u squared du, which is what the original equation was, only with u and du substituted in there. And then we antidifferentiate using the power rule, and you get u to the third over 3 plus c. And once you plug the u and du back in, you get the quantity tangent theta cubed over 3 plus c.
And that is a basic trig u substitution example. And now we're going to move on to something that's very important with u substitution, which is definite intervals.
Here we have an example of u substitution with a definite interval. And our example is a definite integral. Wait. Our example is the definite integral from 0 to 1 of x squared over x cubed plus 1 dx. So in this problem, our u is x cubed plus 1, which is on the bottom, and our du is 3x squared dx, which is just the derivative of u times dx. So in order to get du, you have to multiply your integral by 3 inside of it, and then you do the reciprocal on the outside. So now we are putting the integral in terms of u. Okay, so now the integral and the limits are going to be in terms of u. So we write 1 over u times du. Once you go u, you can't go back. So the next step is to do the anti-differentiation and organize slower. So we have ln the epsilon of u. Right, so we plug each of the limits in for u, and we just upper minus lower. So ln of the absolute value of 2 minus ln absolute value of 1. And since we know that the ln of 1 is 0, we can just write 1/3 times ln the absolute value of 2. We call the upper limit. And this is equal to ln of 2 over 3.
I'd like to say thank you for watching the video. So, thanks. We hope you have a better understanding of U substitution.